All right, let's go ahead and get started today. We're going to skip over a little bit of distributed systems so we can at least move on to other topics for a little while before we jump back. But today I'm going to talk about general multimedia systems, a little overview from your book. And the book went into a sub-process or an example called Cineplex, I believe. We're going to jump out of that and go into a more modern implementation, namely cloud architecture, and then hopefully a little bit about how Netflix actually works in the background. Okay. So we'll talk about multimedia compression and then how do operating systems deal with how multimedia works. Hopefully, or you'll probably experience this where you have buffering coming from Netflix. So the operating system has to handle a little differently because it's a little bit more of a real-time system than what we're generally used to of you click and then hopefully the computer comes back at some point. All right, yeah, we'll talk about the different data compression, of course, different scheduling as well. All right, multimedia, most of us are probably used to this, MP3, MPEG files, a lot of times with webcasts as well. Can be delivered, PCs, although today pretty much everyone uses a smartphone. I don't know if anyone uses a PDA anymore. Do people at baseball use PDAs even? No, not. Yeah, a little dated, but that's all right. Everyone's with smartphones nowadays. All right. So it's stored just on the file system, just like everything else. Usually the frame rate is 24 to 30 frames per second. That's usually chosen. You okay with that?
I think I need 60.
You need 60? When do you need 60?
All the time.
All the time. 24 to 30 was chosen. 24 is what film usually is run at. But they found that in general 30 frames per second is fine for most humans out there. We do have to synchronize the video and the audio. You'll find out that those two tracks are recorded separately. They're not, even though they may be contained in one file, they're two separate data streams that need to be read. Going on to streaming, just like with Netflix when you're streaming it from the internet. There's two different ways to go about it. We have progressive, where the client playback of the file as it's delivered, but then it's ultimately stored, and then there's real-time streaming where the idea is it just comes in, you may have a temporary buffer on your machine that is used to at least play it, and then maybe you can rewind a little bit. All right. Can anyone tell me why you'd use one over the other?
Progressive, if you want to be able to jump around in the file.
Yes, that's pretty good. And then
If your internet sucks.
Real-time streaming, if it's a live webcast.
sure, live webcast, but if you wanted to play back on the live webcast, progressive seems like it'd be pretty good.
Just record it.
You could just record it then. All right, but then why would you want real-time streaming? Okay, live, it makes some sense, yeah.
Thin clients don't have a lot of storage capacity.
Right, there might be some hardware limitations as well. The other thing with real time is a lot of people want to try and do some type of a DRM where you can't actually download it, you have to use the service, so make sure you always pay for it. And that's also another reason for doing a real-time streaming as well. Which one do y'all prefer?
I prefer the progressive download. I like to keep stuff.
Yeah, to keep stuff. Yeah, I'm with you on that. Most people like to keep or hold on to their own things. So usually you want progressive, but you don't always get it. Okay, real time. Yeah, live streaming or on demand. That's, movies, so forth and so on. The events are not delivered in real time. Yeah. Maybe they're stored and then played later. All right. So some characteristics that are actually different than your average. First off, they're quite large. Most files on your operating system are usually very small, so this is going to be a unique case. They're also continuous data, may require very high data rates. One actual advantage of using these files is that they're sequential, so you can read them in large chunks and move on. But usually they require very high data rates. In movies especially, you may get up to megabits per second that you need to be computing or processing on. Oh, compression. Actually, has anyone ever dealt with uncompressed video before? I don't think they even use that anymore.
Technically, like, I think like I took a video on a camera once and it was uncompressed. And
Oh,
then,
wow.
Or like when you record something on your computer back in the day, you had to compress it if you wanted to put it on YouTube or something.
How much time were you able to store?
Not a lot, like a few minutes took up a few gigabytes.
Yeah, it takes up a lot. And even an old compression stream, MPEG 1 actually did a pretty good job of knocking that down. Of course, now we have 2 and 4, and there's actually others as well. It's interesting if you go out there and you watch them, new compression schemes come out all the time that are usually just incremental improvements. But the problem is you'd have to try and distribute that out, and we already have, MPEG 4. We already have Blu-ray players, so you'd have to update all your hardware. Yeah, other levels of MPEG that are in research stages, basically they just, as they research new ways to compress the video, they come up, they'll eventually gather them together and then probably encase them like MPEG 5 or whatnot. And what these compressions are actually doing is they're just removing certain things that the human eye can't see. Because we do store things in red, green, blue, but we can't actually see all those different colors. What was it, 16 million different colors. Can't quite see the difference between all of them. So these are just techniques to try and remove those in order to reduce the size of the file.
Random question.
I love
So
that.
you know how like GIFs are like take up a lot of space?
Mhm.
How come those HTML things take up way less space?
HTML things. You mean the HTML file? Or?
I think so. There's like HTML images or something, HTML5 videos, and they take up way less space.
So HTML, if you actually open it up, all that is the text with the tags with all the information
Yeah.
in, and all those videos that you're talking about, it actually doesn't store them in the file. It stores a link to somewhere else, and then you download that file to wherever it is. So if it's on a web page, and for example, you may have YouTube's an easy one because you just have a link to YouTube. You're not storing the whole YouTube video inside of HTML. Yeah, bring it up. I'll look at it. All right, good. And now we finally get to go into a really good topic here for operating systems, which is quality of service. Let's see. It has to guarantee some type of data rate, otherwise your video will not be able to play back correctly. So this idea of quality of service comes into play. It's also used in networking. You'll actually, when we talk about networking, or if you take advanced networking, do we do quality of service? No. So there is actually ways inside of networking to set up certain lanes throughout the network to ensure that a certain bandwidth is guaranteed in latency. Similarly, with multimedia, you want to guarantee a certain frame rate or a certain resolution as well. All right, but for the OS, usually it's how much CPU you have, how scheduling, so how often it can run, maybe your file system, either how much space you have, as well as how quickly your file system works, and then any type of network protocol. Best effort, soft, and hard. Okay, that's true. So the hard is probably what everyone's thinking about, where you absolutely guarantee a certain quality of service. Although, how often do you think you can do this one?
Not very often.
Not very often. You're going to have to be on a very dedicated piece of hardware connected. Are you going to get this over the internet?
Not the CSU Wi-Fi.
Not the CSU Wi-Fi. We'll say definitely not over the network at large either. Soft, you might be able to prioritize, but you don't really guarantee it, so there might be something in the background that you can at least give a lower bound for. And then best effort, you're basically just flagging it, saying, hey, look, we really need this, we're really questioning it, please give it to us. Usually 1 is what ends up happening, just due to the fact that the network is, or the internet is just a sprawling architecture. All right, throughput, delay, jitter, and reliability. So these are 4 different topics. They're highlighted and bookmarked, or not highlighted, they are bolded in your book, so important. Throughput is the amount of work. This is similar to what we were talking about earlier with servers. How much data can you put through given a second, not necessarily your latency, which it goes back to your delay, time from the request to submit it back. So delay and latency are going to have similar definitions here. Jitter. All right. Let's see. Have y'all dealt with jitter before? So what was jitter when you dealt with it?
When things are random.
When things are random. Okay. So with quality, with the playback, you want it to be a constant stream coming down. But what ends up happening due to how networks operate is there might be some extra delays here and there, and that's usually
Random intervals.
like random intervals. Perfect. So that's usually what we talk about jitter here. So you need to come up with a way to deal with jitter. How do you think we do that?
Ignore the problem.
Ignore the problem. Great answer.
Cache it.
We cache it, right?
Buffer.
But in this time we don't call it a cache, we call it a buffer instead. But it's the same thing. We just basically preload a bunch of information, in the future that's coming down, and then if you have jitter, hopefully that delay is contained within the buffer and we can move on. Reliability, how are errors handled? The network goes down. What happens to your video? Well,
Lose it.
you lose it. Well, you could lose it, or hopefully it just pauses and then tries to wait for it to load or rebuffer and then move on from there. Okay, so those are the 4 main qualities of or parameters for quality of service. Any questions? All right. It can be negotiated. If you think about this, if you're on a huge network with many connections, there might be a lot of negotiation about who gets the quality of service, especially since once your load becomes high enough, you're not going to be able to serve everyone at the same time. And yeah, this is often a mission control algorithm as well. All right. Yeah, so this is where, okay, resources on a file server. Hopefully, this is not new to any of us. Processors, maybe a buffer space. This is usually in your RAM of all the information. You try and read from your primary or your secondary storage, and you might have your tertiary storage, which might be something else, either through another network connection or through, or just on the hardware as well. But the main point of this is that there's a significant buffer space. Usually this is actually fairly large when it's trying to read in all the information, because going to your secondary and your tertiary can have a significant delay, especially under heavy load. All right. So CPU scheduling, well, hopefully here it's not too complicated. You just need to make sure that you schedule your CPU with your process, give it the right priority, so that it can actually take advantage of the resources you have. The nice thing here is you know beforehand how much computational processing you need, so that type of scheduling is a little easier than the dynamic that we've had to deal with in the past. Okay, disk scheduling. Now this one's going to be a little different. Earliest deadline first. What other types were there beforehand?
Shortest job first.
What was that?
Shortest job first.
Shortest job first.
Jump first.
Well, yeah, shortest jump first.
Yeah. SJ.
Now, SJ. And what were those optimizing?
The time it takes to get a set of queries done.
Right. So they had a large set of queries, and they wanted to finish doing all of them as soon as possible. Earliest deadline first. What's that one doing instead?
Trying to make sure you get the data out before you actually need it.
Right. So now we've actually added priority. Is the word we're usually looking for. We've added a priority to the data that's being requested. So now it may take a lot longer to service everything, but hopefully the important pieces are serviced sooner. Okay, uses a queue. Probably is going to be a priority queue, actually, since we're going to need to add some level of priority to it. Okay. We're going to skip this for now. Yeah. There we go, network management. Y'all do unicasting, broadcasting, and multicasting inside of advanced networking, or actually applied networking?
More or less. I think we just talked about it.
We just talked about it, but
Yeah.
didn't go into it too much? Okay. So here we have three main different ways to broadcast it. Unicasting is what we think about most of the time. It delivers the content to a single client. So this is point-to-point communication from your server to your client. Broadcasting, it's going to actually go to all clients, whether they want it or not. So it just sends it to everywhere. And then you have multicasting, delivers it to a group. See what a good way to ask this. So when you're using internet and Netflix, which one of these three is usually happening? Unicasting is usually what's happening.
You have multiple people in the house, though.
If you have multiple people in the house, but you're on Netflix, and Netflix is
But if they're
in
all
the-
watching different shows.
if they're watching different shows, and those are different streams.
Or wait, wouldn't it be multiple people were watching it, though?
At the same
multiple
time?
people were watching the same thing in different houses, or?
Twitch TV uses multicasting.
Okay, how does Twitch work?
It's a live stream. Anybody that wants to watch it loads the web page and they start receiving the stream where it's at.
Okay, cool.
Yeah, that would actually be it because they're all getting the same thing.
Mhm.
But with Netflix, if I started 5 minutes later, I'd be getting different.
And then cable TV does broadcasting.
Cable TV does right, sends it out to everyone. Perfect. Everyone got it? All right. Okay, real-time streaming protocol. Let me step back for a little. We've talked about a lot of different topics, but we haven't really talked about a protocol so far. Most of the time, when you're viewing things on the internet, it uses HTTP. Here, if you recall, HTTP is stateless, which means every request has to be fully encased by itself. And what was the problem with that? What's some issues that we thought about?
Ooh, back in the applied
Back in
networking
applied?
days.
No, I think we talked about it here. Was it because it's stateless versus stateful?
Stateless versus stateful.
Because stateful, you had to encompass the entire request in one package and ship it over. While with a
Stateless, you have to do it every time you want something.
maybe I said that backwards. Stateless is where the package has to be one whole thing, you ship it over. Stateful is where you usually say, hey, I'm going to open a connection, you do some stuff,
Yeah.
and then you close the connection afterwards.
Yeah.
What was the advantages of those two?
Stateless was the one where you had to do several different ones, though, right?
Not necessarily, because if it all fit inside of one Ethernet packet, it could just go.
But if you had something that wouldn't fit inside one,
You'd have to split it up, yeah. But same thing with the stateful one, because you'd have one packet to do, hey, I'm opening connection, hey, I'm writing here, hey, I'm reading here, writing, and then eventually you get out. You'd be done at the end. The question is, or here's the question, which one has better performance?
Stateful,
And why is that?
because you can leave a connection open and you don't have to send the overhead of opening and closing the connection with each request.
Right. So HTTP is stateless. With multimedia, we usually have very high performance requirements. So naturally, we're going to need to come up with something that is better performance, and hence real-time streaming protocol came about in order to adhere to or fix the problems of HTTP. Okay. Sure, so client, this is just to talk about a high view of what's happening. Web browser goes to the web server, asks for at least, hey look, I want to stream this file. Gets back the metadata. Remember, the metadata or the meta file is what talks about the information. Client gets the meta file, then can request it from the player, which gets the media stream, and then that's when your real-time stream would actually be hooked up. So a couple important things, architecture-wise. Your first request is actually for the metadata, the information on the file, so the client knows what's coming down, aka how big is the file. You usually load up YouTube, one of the first things that comes up is tells you how much time it has. It's looking at the meta file first. And then later it's going to go ahead and do the full request of what the file needs to be, or what the file information is, or the file itself. Because another thing in the meta file might be, what's your compression? Are you doing impact 4, impact 2, et cetera, et cetera. All right. Okay, that was the old one. It's the same thing here, except for real-time stream is requested on the bottom, and then it's sent over. Same thing. All right, you can set up, play, pause, and then tear down. Similar to opening a file, you set up, aka open. You can play to start reading, pause to say, hold on, don't need anything right now, or the user has paused it, and tear down, aka close. But there's no write. Obviously, that doesn't make any sense here.
Kind of pointless.
Kind of pointless in this one. All right, state machines, you initialize it, that's the setup, then you can go to play. You can play it, you can pause it, back and forth, and then you can tear down. Actually very similar to a file. All right. This is where, when I was looking at these slides, I decided that we need to go ahead and take a break. Cineblitz is pretty old, and there's been a lot of changes, especially with cloud and Netflix taking over since these slides were created. So we're going to stop here and jump over to at least a couple of other presentations.